We'll explore file systems, which manage how data is stored, organized, and retrieved on a computer. A file system provides an interface for users and applications to create, access, and modify files efficiently. Key topics include file concepts, access methods, directory structures, file system mounting, file sharing, and protection. A well-structured file system ensures data security, organization, and optimal system performance. A file is a collection of related information stored in a contiguous logical address space. IT serves as a basic unit of storage for users and applications. Files can store data, such as numeric values, characters, and binary content, or programs that execute various tasks. The way data is organized within a file impacts performance and accessibility. Different systems support different types of files, making it easier to work with structured and unstructured data. The file system plays a crucial role in managing files, ensuring they are stored efficiently, retrieved quickly, and secured properly. Without a structured approach to file storage, managing large amounts of data would become chaotic and inefficient. Files can have different structures depending on how they store and organize data. Some files have no defined structure, acting as simple sequences of bytes or words. Others follow a record-based structure, where data is stored in fixed or variable length records. More complex files, such as formatted documents or relocatable load files, use predefined structures for efficient processing. The operating system often determines the structure, ensuring data integrity and ease of access. Proper file structuring allows programs to interpret data correctly and optimizes storage usage. Additionally, file systems may insert control characters to simulate structured data within unstructured file types, ensuring flexibility and compatibility. Each file in a file system has specific attributes that define its properties. These include name, the human-readable identifier used to access the file. Type identifies the file. Format useful in systems that support multiple file types. Location, the physical storage address, where the file resides on a disk. Size indicates the current length of the file in bytes. Protection determines who can read, write, or execute the file. Time, date, and user identification stores metadata for security, monitoring, and access control. These attributes are stored in the directory structure and help the operating system manage files efficiently. Without these attributes, organizing and retrieving files would be difficult and inefficient. A file system must support various operations to enable users and applications to manage files efficiently. These operations include create, generates a new file and assigns attributes such as name, type, and location. Write stores data into a file at a specified location, either appending new data or modifying existing content. Read retrieve stored data for processing or display. This allows users and programs to access information without modifying it. Reposition seek moves the file pointer to a specific location, enabling random access within a file. This is useful for direct access files. Delete removes a file permanently, freeing up storage space. Deleted files may be recoverable depending on the system. Truncate reduces the size of a file while preserving its structure, removing excess data but keeping the file intact. Additionally, files must be opened before use. When a file is opened, its metadata and structure are loaded into memory, allowing quick access. Once operations are completed, the file must be closed, ensuring all changes are saved and system resources are freed. File operations are crucial for efficient data management, allowing users to create, modify, and organize files effectively. These functions ensure system stability, data integrity, and optimal storage. Utilization. Files are classified based on their name and extension, helping both users and the operating system identify their purpose. File name, a unique, human-readable identifier used to access the file. Extension, a suffix that indicates the file type, e.g., .txt for text, .jpg for images, .x for executables. Extensions help the system determine which applications can open a file. Some operating systems enforce strict file extensions, while others rely on metadata or file headers to recognize formats. Common file types include text files, .txt, docs, store, readable content. Executable files, .x, .app, contain programs that run on the system. Multimedia files, MP3, MP4, .jpg, store audio, video, and images. Compressed files, .zip, .rar, reduce file size for storage and sharing. Using proper file types and extensions ensures compatibility, security, and efficient organization, helping users and applications manage data effectively. Files can be accessed using different methods based on their structure and usage. Sequential access. Data is read and written in order, one record after another, similar to a tape recorder. This is simple and efficient for reading large blocks of data but lacks flexibility for quick access. Direct access allows access to any part of the file directly using relative block numbers. This is useful for databases and large structured files, where specific records need to be retrieved quickly. The choice between sequential and direct access depends on the application's requirements. While sequential access is efficient for logs and text files, direct access is ideal for structured data, such as databases and multimedia files. Sequential access is one of the simplest file access methods. In this method, reading is done in a specific order, moving from one record to the next. Writing follows the same sequential pattern, appending data to the end of the file. Resetting returns the file pointer to their beginning. Rewriting modifies existing content but cannot overwrite random sections easily. A sequential access file is efficient for tasks such as log management, streaming, and batch processing, where order matters. However, it lacks the flexibility of direct access, making modifications and random searches slower and less efficient. A file system organizes and manages files effectively using directories, store metadata, and maintain file locations. Mounting integrates external or removable storage devices into the system. File sharing allows multiple users or processes to access files securely. Protection mechanisms ensures restricted access, preventing unauthorized modifications or deletions. The file system ensures data consistency, optimizes performance, and enhances security. A well-organized system simplifies file retrieval, improves storage efficiency, and protects data from loss or corruption. Understanding how file systems work is essential for effective file management and system administration.